Welcome to our channel Sankalp Study Success. Today in this video we are going to learn about what is the derivation tree and also the two most important terms, the leftmost derivation and also the rightmost derivation. So that means here we are going to see what is the derivation tree and how to solve the derivation tree. That means in order to draw the derivation tree, what the steps we are going to take, and also what is the leftmost and the rightmost derivation. These three topics here which we are going to learn in this video are the most easiest topics and we can learn it very easily. So now let us see what is the derivation tree actually is. So here the derivation tree. In this derivation tree, first of all let us define the derivation tree here, which is nothing but the pictorial or the graphical representation of derivation. Okay, graphical representation of derivation. Which is known as the derivation tree. That means from the name itself, if you see, it is nothing but a tree. Tree is nothing but it is the pictorial or the graphical representation of the derivation, right? And now this derivation tree, it is also known as parse tree, or it is also known as syntax tree. That means derivation tree, parse tree, syntax tree, all three are one and the same. So now if you see in the tree, it is nothing but you will be having several kinds of nodes, correct? So if we consider root node, or there will be leaf node and also the internal nodes, correct? So this root node, for this root node, it is nothing but this root node determines, or this root node indicates the star symbol. This indicates the star symbol. That means our derivation tree starts from root itself. And here the leaf node indicates input string. That means if you combine all the leaf nodes present in the derivation tree, then you will get the input string. Finally, you will end up with the input string. And here internal nodes. Internal nodes are nothing but they are variables. That means for each and every internal node, we are going to substitute in the place of variable. Generally, for variables, we are going to substitute the terminals, right? So, for the internal nodes, we are going to substitute the variables in order to get the leaf nodes, which are nothing but our input string. So, this is about derivation tree, where this derivation tree is nothing but the pictorial or graphical representation of derivation, which is also known as the parse tree or the syntax tree. And in this tree we are going to have root node, leaf node and also the internal nodes, where root node is the start symbol, leaf node is the input string and the internal nodes are the variables. So here let us see one of the example of derivation tree. Here construct a derivation tree for the string AA, BB, ABBA. That means what? For this input string, we are going to construct a derivation tree. See here, AA, BB, ABBA. This is the input string which is given in the question. Now, first of all, in order to draw the derivation tree, the first step is you need to derive the derivation for the given input string. So, how do we derive the derivation? From the context-free grammar which is already given here. So first let us derive the derivation, where our context-free grammar starts from S, right? So S tends to, here we are having AB or BA. So we need to consider any one from AB or BA. So how do we consider is we are going to check from the input string if here input string is starting from A. So A is nothing but here it is AB. So we are going to consider small a and capital B here. Now we are done with the first A. Now we need to continue substituting from capital B, right? In the place of capital B, you can substitute either B or BS or ABB. So, but if you observe carefully, our input string is starting from A, right? Because the second input symbol is A. So here it is A and then we are going to substitute ABB in place of capital B. Now here we are having two capital B's, that means two non-terminals. So in place of first B and in place of second B, we need to substitute. In the place of first B, here there are two A's, we are done with two A's, and here in the place of first B there is a small b. So here you have small b and bs, and here it is not ending up here because we are having one more capital B, so you can substitute small b. AA, small b and capital B. Now in place of capital B, again it is starting from B and it is not the end of the string. That means if you substitute this B, it will be the end of the string and we will be ending up with AABB. But it is not the end of the string, it is BS. So we are going to substitute AAB and BS, right? And now here in place of S, here what are we going to substitute, either AB or BA? We are going to see from the input string. After AABB, it is starting from small a. That means it is A and capital B. So we are going to substitute AABB and A capital B. Now in place of B, here it is starting from B and it is not the end of the string. That means we are going to substitute BS. So here's AABB, A and BS. Now if you see, it is again starting from BA. So that means in the place of S, here it is starting from small b. So here we are going to consider BA. So AA, BB, AB and it is BA. So now if you see in place of A, you can substitute either AS, A or BAA. So what are we going to substitute? Here we are left out with only one input symbol, that is small a, and it is the end of our input string which is given in the question. So here we are having only the single a, so this single a can be substituted in place of capital A. A, B, B and small a. So this is the derivation which is given for the input string which is given in the question. So finally we are done with the derivation. So now we are going to draw the derivation tree. How are we going to draw the derivation tree? Which is nothing but it starts with the root, which is the start symbol. Here the start symbol is nothing but S, correct? So here our root is S. Now in the place of S we are going to substitute AB or BA, correct? So here in the derivation, in which order you have substituted all the values, in the same order we are going to derive it in the derivation tree also. So in the place of S you have substituted AB. So here it is small a and here it is capital B. Now in the place of B you have substituted ABB. So here let us write it is A, capital B and capital B. And then in this capital B we have substituted small b, and in this capital B we have substituted BS, correct? So now in the next step, in the place of S you have substituted small a and capital B, correct? So let us write here small a and capital B. And then again in the place of capital B we have substituted BS. So it is small b and small s. Then in the place of S we have substituted BA. So it is nothing but small b and capital A, and in the place of A you have substituted A finally, and we are ending up over here. Now if you consider, it is the root node which is starting from S. This is the root node which is our start symbol, and the thing we have learnt is all the leaf nodes if you combine, then you will get the input string, right? So if you see from all the leaf nodes from left to right, so here A, the next leaf node is again A, and then it is B, then it is B, then A, B, B, A. So A, B, B, A. So if you see, this is nothing but our input string which is given in the question. So that means if we are ending up with our input string, then our derivation tree which we have drawn is correct. So in this way we are going to first of all derive the derivation, and then we are going to draw the derivation tree for the given input string. So now let us see what is the leftmost derivation and also the rightmost derivation. So here it is nothing but LMD or RMD, correct? which is the leftmost derivation and the rightmost derivation. Till now we have learned what is the derivation tree, and we have also solved a problem related to derivation tree. But now, what is leftmost derivation and what is the rightmost derivation? Here, the leftmost derivation is nothing but if there are two or more non-terminals in a given question, or that means if you are solving S tends to A, B, B. Just now we have solved it, right? So there are two non-terminals, capital B and capital B. This is the leftmost and this is the rightmost, correct? So in the leftmost derivation, wherever you get more than one non-terminals, then the leftmost should be substituted first and then followed by the remaining. That means the leftmost is substituted if here S tends to capital A, B, C. If you are having this kind of production, here you are having three non-terminals where the leftmost is nothing but A, right? So first we are going in the leftmost derivation. If you consider here, we are going to solve for leftmost derivation. Then we are going to substitute capital A for the first one, then for capital B, and then for capital C. So from the left to right, we are going to substitute the values in the leftmost derivation. But if you consider rightmost derivation, for the same production S tends to A, B, C, here the rightmost non-terminal is nothing but C. So we start our substitution from the right side to the left side. That means first we are going to substitute the rightmost variable or non-terminal, which is C. Then we are going to substitute for capital B, and then we are going to substitute for capital A. So these are nothing but the leftmost derivations and the rightmost derivations. So now let us solve some of the problems related to leftmost derivation and rightmost derivation so that we can be very clear in this topic, right? So here leftmost derivation and rightmost derivation. We need to construct both the leftmost derivation as well as the rightmost derivation for the string which is A plus A star A plus A. And here our context free grammar which is given in the question is E tends to E plus E or E star E or E or A. This is given in the question itself, so don't worry, this completely is the question from here to here. It is completely the question. I forgot to write it over there. So construct the leftmost derivation and the rightmost derivation for the given string A plus A star A plus A. Now here our string starts with capital E, right? That means our context free grammar starts with capital E. So you need to first derive this expression and then we are going to draw the derivation tree if it is asked in the question. Here it is asked only the leftmost derivation and the rightmost derivation, so there is no need to draw the derivation tree here. Now let us solve it for leftmost derivation. Okay, first we'll solve it for left and then we'll solve it for right. Now E tends to, we need to consider any one of the production from E, right? So let me consider E tends to E plus E. Now if you observe, both the E's are the non-terminals. So in the leftmost derivation, we are going to substitute for the leftmost capital E, right? So for the leftmost capital E, what do we need to substitute? Here, if you substitute E plus E, then it becomes E plus E plus E, which is not our expression, right? If you substitute E star E, we are already with plus E, and if you substitute E star E, it becomes E star E plus E. So if you observe, we got this, right? But in place of A, we are having E. So here there are three non-terminals again. So from these three non-terminals, from where we are going to start our substitution? It is from the leftmost one. That means from this E. From this E, we are going to substitute. In place of this E, if you substitute E plus E, then it becomes E plus E star E plus E. Now if you see, this input expression which we have is the same expression which we got here, but in the place of A we are having E. But if you observe in the context-free grammar which is given, in the place of E, you can also substitute A. So as it is the leftmost derivation, first you need to substitute the leftmost E and then followed by the next, correct? Now again we are having the three non-terminals. So the leftmost non-terminal should be substituted first. So A plus A star E plus E again. Now there you are again remaining with the two non-terminals. So we need to substitute the leftmost one, which is this E. So it is A plus A star A plus E. And then at the end we are having only one non-terminal and we are going to substitute it with A. So it is nothing but A plus A star A plus A. So we got the given input expression, correct? So we have constructed the leftmost derivation for the given input A plus A star A plus A. Now we are going to solve it for rightmost derivation. See here, in the exam point of view, if we are going to solve this problem in our semester exams, then wherever we are going to substitute here, then you need to write that we are substituting the place of E, where E tends to E star E here, right? That means whatever the production you are using, because in the given context-free grammar, there are 4 different kinds of productions for the single E, right? So we are going to confuse whether you are substituting which production. So in order to know, and it will be crystal clear if you write the production which you are using in the beside of that expression, correct? So in the exam point of view, you are going to derive this, and also simultaneously you are going to write the production whichever you are using in the place of the leftmost non-terminal. So now in the same way, in the place of rightmost non-terminal, whatever the production you are substituting, then that production you are going to write it beside there, so that we'll come to know that in this particular step you have substituted this particular production, correct? So here now let us solve it for rightmost derivation, where E tends to E plus E is the production which we have. So the rightmost derivation is nothing. In the rightmost derivation, we are going to substitute for the rightmost non-terminal, which is nothing but E in this case. This E, not the left E, which is the right E. So here, if you see the input string which we have, this input string is starting from A plus something, right? So we are already having E plus something. Here, if you see, it is A star A. That means in place of right E, you can substitute E star E, right? E plus E star E. So that we got A plus A star A till here, but in the place of A, we are having E. So again, we are having 3 non-terminals, where you are going to substitute for the rightmost non-terminal. In the rightmost non-terminal, if you substitute again E plus E, then you will get our own equation which is given in the question. In the place of E, we are going to substitute E plus E. But here, we got the expression as it is, but in place of A, we are having E. So here in the production, we are also having E tends to small a. So how do we going to substitute is from the right side, because it is the rightmost derivation. So rightmost E is substituted with small a. So E plus E star E plus small a, and then again the rightmost E is substituted with A. So E plus E star A plus A. Then again the rightmost one, which is E, it is substituted with E plus A star A plus A. And then the remaining one term, and also from the right side, this is the one term which we have, which is E. So this is also going to substitute with A. So it becomes A plus A star A plus A. This is our input string which is given in the question. So in this way, by considering the leftmost and the rightmost non-terminals, we are going to substitute. So in case of leftmost derivation, we have substituted from the left side, and in the case of rightmost derivation, we have substituted from the right side. So this is the problem, one of the problem which we have. Now let us solve one more problem where we need to construct the leftmost derivation and rightmost derivation for the input string 1 0 0 0 1 1. Here we are given with 1, 000 and 111, where you are going to first derive the leftmost derivation and the rightmost derivation. So first let us go with the leftmost derivation. Here in the leftmost derivation, we are using the context free grammar, this context free grammar, correct? That means you are starting from the star symbol S. So here our S tends to capital T, 00 and again capital T, right? So here if you see the leftmost derivation, that means what? Here we are going to substitute in the place of left T, correct? So in the place of left T, if you carefully observe, it is starting from 1. So our input string also should start with 1. So let us substitute with 1T first. So 1T, 00 and T. And again if you observe, it is followed by 00. So you are having already 00 and there is a T in between here. And here we are having epsilon as well, correct? So, and also you have 0T. So you can substitute either 0T or epsilon. Here, if you substitute epsilon, then you will have only 2 zeros. But here, if you substitute 0T, then it becomes 1, 0T, 00T. So here, we are having again two non-terminals, and also from the left we are going to substitute for in the leftmost derivation. So if you consider this T, and in the input string which you have got, you have already 3 zeros, and here in the input string also you have 3 zeros. So you need to end up with the zeros, and then you need to start with ones, correct? So in order to end with zeros, in the place of T you can substitute epsilon. So it is nothing but 1 0 epsilon 00 T, where epsilon is nothing, it is a null. So 1 000 T is the string which we got. So in the place of capital T, here 1 000, here already we are there till 1 000 and we are there with 111, correct? So in the place of T, it is starting with 1T, so we are going to substitute 1T, 1 000 1T. And then again in the place of T we are having 1. So 1 000 111T, and also here ending with 1. So in the place of T we are again going to substitute 1T. 1 000 111T. If you carefully observe, we are done with our input string 1 000 111, but still we are having one more non-terminal. So in order to remove that non-terminal, we can substitute null here, because there is a production T tends to null. That means epsilon. So let us substitute 1 000 111 and epsilon with the T. So here, if you remove epsilon, then you will get it as 1 000 111. So this is nothing but the leftmost derivation for the given input string. Now for the same string, we are going to draw the rightmost derivation. That means we are going to derive the rightmost derivation, right? So even for the rightmost derivation, we are going to start with S tends to T00T, because S is the start symbol. Now if you observe, for the right T we are going to substitute first, that means for this T. So now here you are having already zeros, correct? So now we are going to do it once actually. So here this T will be as it is, because it is the left one. So 00, and this T you are going to substitute with 1T in order to get 1. Then again for this T we are going to substitute with the 1T, because we are having 3 ones. So we need to end up with 3 ones. So again, so here we got 2 ones. Then again if you substitute T with 1T, then you will get it as 1 000 111T. So here it is the end for the 111. There is nothing more zeros or ones followed by 111, correct? So in the place of T you can substitute epsilon in order to end it up here, which is nothing but T 000 111. So here if you observe, for 1 000 111, here 000 111 is already done, correct? So here we are having 0. Before this we are having 0 and also 1. So here if you substitute 1T in place of T, here 1T 000 111. and in the place of this left t, because it is the left t or the right t, there is only one t, because here you cannot identify whether it is the left one or right one because it is only single t. So in this single t we are going to substitute with 0t in order to get 3 zeros, right? 1 0t and 00 111. So if you remove this t, then you will observe that we have already got the input string, which is 1 000 111. So in order to remove this t, we are going to substitute with epsilon, where 10 epsilon 00 111. So this you will get it as 1 000 111, which is nothing but our input string which we have. So in this way we are going to derive. First you need to analyze the question from the context free grammar. You are going to just derive it, but in the leftmost you are going to derive from the left side, and from the right, in the rightmost you are going to derive from the right side. Just that's the difference which we have. Now let us solve one more question here, where construct the leftmost derivation and rightmost derivation for the input string which is given BA BB AB for the context free grammar, and our context free grammar is given. So we are going to derive for the leftmost derivation and also for the rightmost derivation, and our input string is BB AB, right? This is our input string which is given. So for this input string, here we are starting with S tends to AA, right? Because S is the start symbol, so where we are going to start with S tends to AA, and here in the place of left, it is the leftmost derivation, so in the place of left A we are going to it is starting with small b, so for the left A we are going to substitute with BA, because here it is, we are not going to substitute just A here because it is starting from B, and from starting from B there is only one production, so we have chosen BA, and also the next A will be as it is. Now this capital A, there are two A's, that means there are two non-terminals, so again you need to substitute from the leftmost one. So in the left thing, if you see, there is A, right? So you also having A production here. So let us substitute as it is BA and capital A. So in the place of capital A, it is starting again from B. So you are going to substitute in place of A, BA. So AB, B capital A. So if you see, in the place of capital B, we are again having B. So we are going to substitute with BA only. BA. So BA, BB is the string which we got, and we are having AB here. So in the place of A, if you substitute only A, then you will be ending up there itself. So you are not going to get the small b again. So what are we going to do? It is ending with B, right? So if you substitute AB, BA, BB and capital A, small b. So here if you substitute A, then you will get our input string, correct? So small a, BA, BB, AB. This is nothing but our input string which is given in the question, and it is the leftmost derivation because from the left side we have derived it, right? So first you have to see the context free grammar. From the context free grammar you need to choose which one should be substituted in place of non-terminals, correct? So then you will get the exact answer which we want. Now let us go with the rightmost derivation here. In the rightmost derivation also we are going to start with the start symbol AA because it is the start symbol is S, so we are going to start with S tends to AA, and then here as it is the rightmost derivation we are going to substitute from the right side. So we are going to substitute the right A and then we are going to substitute the left one. So here if you see, in the right side you are ending up with small b, so you can use AB here. So we are substituting A and AB. So again you have two non-terminals, so you need to start with the rightmost one which is this A, and in the place of this A we are having small a, right? So let us substitute small a as it is. So you are going to get with capital A and small AB. Now we are having in place of capital A it is BB. That means here you can substitute it with AB, right? So it is AB, AB. correct? So again, if you substitute capital A with AB, then you are going to get two B's here and followed by AB. So here for the input string AB, BB, AB, here BB, AB is already done. So we have to have B and A. So how do we get BA here? Because in place of A, we are starting from B for this production only. So we are going to substitute BA, BB and AB. So if you observe, in the place of A, if you substitute this A, then you will be ending up with BA, BB, AB, which is our input string given in the question, correct? So let us substitute BA, BB and AB. So this is our final input string which is given in the question, and this is the rightmost derivation. So here we are having the leftmost derivation and the rightmost derivation. From the context-free grammar, we are going to derive it. So now let us see the next question, which is for the grammar S tends to A1B, A tends to 0A or epsilon, or B tends to 0B or 1B or epsilon. For this context-free grammar, you are going to draw the leftmost derivation and the rightmost derivation for the input string 00101. So for this input string 00101, you have to derive the leftmost derivation as well as the rightmost derivation. So now let us start with the leftmost derivation. And here for the leftmost derivation, anyhow we are going to start with our star symbol. S tends to A1B. Here in the leftmost derivation, we are going to substitute for the leftmost non-terminal, that is A here, because we are having two non-terminals A and B. So for the A, we are going to substitute here. If you observe here, our input string is starting from 0. So in place of A, we are going to substitute 0A. So 0A and 1B. Again in place of A, we are having one more 0 before this one. So we are going to substitute again with 0A and 1B. So here, these two zeros are followed by ones and there is nothing in between these two, right? So we are going to remove this A, and because here we are having epsilon production. So here 00 epsilon and 1B, and if you remove this epsilon you will get 001B. So here we are having only one non-terminal, and in place of this capital B, here we are having a 0 and 1, correct? So in place of B, we are going to substitute with 0B. So then we are going to get it as 0010B. And in place of this B, we are having 1B. So here 00101B. So if you carefully observe, our input string 00101 is already done. And we are left with one more non-terminal, which is B here. B, then we are going to substitute with the epsilon. So 00101B, 1 epsilon, because in place of B we have substituted with epsilon, and if you remove that you will get it as 00101. So this is nothing but an input string and it is the leftmost derivation. So you need to remember, for each and every derivation, wherever you are going to substitute the production, you are going to write it beside there, because in order to know that you have substituted that particular production for that particular step. Now let us go with the rightmost derivation here, where we are again going to start with our start symbol. S tends to A1B. So in place of A1B, from the rightmost term, that means the rightmost non-terminal is nothing but the capital B. So in place of capital B, we are going to substitute these productions, right? Any one of these productions. So if you see, there is 1 here, and to the right side of 1 it is starting with 0. So let us substitute 0B here. Then you got it as 10. And then as it is the rightmost derivation, again we need to start with a capital B only. So if you see it here, A10, now we are going to substitute with 1B because it is ending with 101. So again it is the end here, right? After 101 it is the end here. So in the place of capital B, if you substitute epsilon, then it becomes A101 epsilon, where it is equals to A101. And in the place of A, you have to substitute zeros, right? Because before 101 we are having two zeros. So in the place of A, we are going to substitute with 0A. 0A, 101. And in the place of capital A, again we are having one more 0, then we are going to substitute again with 0A. 00A and 101. And if you observe, it is the input string which we got if you remove capital A, correct? Because 00101 is the input string. So in order to remove this capital A, we are going to substitute it with epsilon. So 00 epsilon 101 is nothing but the our input string. If you remove epsilon, then you will get 00101. So from the rightmost derivation, we have derived 00101. In this way, we are going to take the leftmost and the rightmost derivations. Now, let us see one more question, which is consider context-free grammar. S tends to ASA or B, or here A tends to AB or A. Now, you need to construct the leftmost derivation and rightmost derivation, and also parse tree for AA, BA, BA. If you see, there is an input string given here and also the context free grammar, and here you need to derive leftmost and the rightmost derivation, and also we are going to draw the parse tree. So first let us derive the leftmost and the rightmost derivation for the given input string. First, leftmost derivation. Here for the leftmost derivation, we are anyhow starting with S because it is the start symbol, and here what are we going to take? Either ASA or small b. So if you take small b, then it will be the end of our string and you will be ending up with only one small b. So here we are going to take ASA. Now, if you observe, S and A both are the non-terminals and it is the leftmost derivation, so you need to substitute for S, correct? Because it is the leftmost non-terminal. As we are having A here and it is starting with A, so this S can be substituted with again ASA. And we are having A here. Now, we are having three non-terminals, correct? And from the leftmost non-terminal is small s. So, in the place of the third non-terminal, we are having small b here. So in the place of S, you can substitute the small b. So AA, small b, capital A and capital A. Now again we are having two non-terminals, so you need to substitute the left A first. So if you see here, if you substitute left A, here it is small a. So in the place of capital A, you can substitute it with small a or capital AB. So here, if you see for the capital AB, if you substitute capital AB, here it is followed by B. So you can substitute capital AB, correct? And again we are having one more A. So if you see our input string, it is AA, BA, BA. So in the place of each and every A, if you substitute small a, then you are done with our leftmost derivation, correct? So first let us substitute the leftmost non-terminal, which is capital A, and we are substituting it with small a, and the remaining one is also substituted with small a in order to get the leftmost derivation. This is the leftmost derivation for the given question. Now let us also construct rightmost derivation, and then we are going to draw the parse tree. For this rightmost derivation, anyhow we are going to start with the star symbol. S tends to ASA. So here from the right, in the rightmost derivation, we are going to start with this capital A, right? Because it is the rightmost non-terminal. So for this capital A, it is ending with small a, so you can directly substitute small a. So it becomes ASA, right? So there is only one non-terminal S, so there is not left or right. So for this S, we are going to substitute again ASA, correct? Because in the place of ASA, and also one more small a, because it is starting from two A's, and is it ending from for two B's? No, right? Because here, if you carefully observe, as it is AS and capital A, correct? AS and capital A, and we are having one A. Sorry, I have written two A's, right? So let us erase this one more A here. So let us erase this one more A, and now if you see it as AS AA, SA and A. Again, there are two non-terminals S and A here. So then we are going to take it as the rightmost non-terminal, which is capital A, and here if you observe, in the place of capital A from the end it is small b. So we are going to substitute with AB here. For this capital A we are going to substitute with AB. So it becomes AA, S, AB and A. So if you observe, our input string is AA, BA and BA. This is our input string, and from the starting we are done with two A's, and from the end we are done with B and A. Now in the place of A you have small a, right, from the rightmost term. So let us substitute small a over there and BA. Now in the place of S you are left with B, correct? It is only for B and the remaining term is already completed. So if you substitute only the small b, then you will end up with our input string which is given, correct? So it is nothing but AA small b, ABA. So this is nothing but our input string which is given in the question. So here we have constructed the leftmost and the rightmost derivations. Now let us draw the parse tree in between these two. I am going to draw it here. Parse tree. Oh, sorry, it is completely going wrong. So here let us draw it in the next page where it is nothing but the parse tree. So in this parse tree, first anyhow you are going to start with the start symbol S, that is the root node, and here you can draw the parse tree for leftmost or the rightmost derivations, but here I am considering the leftmost derivation, where in the place of S you have substituted ASA. So let us write it here, A, S and A. And then in the place of S we have substituted small b, correct? So let us write it as small b here, and in the place of S, first in the first step we have substituted with ASA, then we have substituted with B, correct? So let us erase this, and in the place of S we have substituted again ASA, and in place of this small s we have substituted B here. Now for the next A we have substituted AB, correct? Here in the place of A we have substituted capital A and small b, and then if you observe carefully, for this A we have substituted small a, and also for this A we have substituted small a. So this is nothing but our parse tree, which is also known as the derivation tree or the syntax tree. So here this is the root node which we know already, and if you see the leaf nodes, that means if you combine all the leaf nodes, then you need to get our input string, correct? So let us see whether we are getting our input string or not. So these are the leaf nodes. From left to right we are going to read it. So the left one is A, then again you are having A, then you are having B, then it is A, B, and again it is A. So this is nothing but our input string AA, BA and BA. This is the this is the parse tree for the leftmost derivation, and also if you draw for the rightmost derivation, it will be one and the same, the parse tree. So in this way we are going to construct the leftmost derivation and the rightmost derivation, and also the parse trees. Now let us see one more question, which is S tends to, this is the context free grammar which is given here, and also the leftmost derivation and the rightmost derivation you need to construct, and then you need to construct the syntax tree for this, for any string. That means from this context free grammar you need to consider any one random string, and then you need to derive that random string using leftmost derivation and the rightmost derivation, and then we are going to draw the syntax tree, which is nothing but the parse tree or the derivation tree. Just the terminology or the nomenclature is different, but the meaning is one and the same. So you need to try it out this question, because the last question was as it is. So using the context free grammar, you can take any string, any input string, any valid input string you need to consider, which is a valid one. you have to consider and then derive the leftmost derivation and the rightmost derivation, and you need to draw the syntax tree for the given question. So this is the question. You can try it out. Try this question. If you have any doubts, then you can comment it in the comment box or you can mail to us so that we can solve your queries, right? So now let us see a small topic, which is ambiguity in context-free grammar. There is another topic here, which is a very small topic, which is ambiguity. Ambiguity is nothing but for the same string, if you are having more than one leftmost derivation or more than one rightmost derivation, more than one leftmost derivation or rightmost derivation, or if there is a more than one parse tree also, more than one parse tree, then that is known as ambiguity in context free grammar, or you can also it is also known as ambiguous context free grammar. Ambiguous context free grammar. So here in the ambiguity, it is nothing but you are going to have more than one leftmost derivation, or if you are having more than one rightmost derivation or more than one parse tree for the same string, then that is known as ambiguity in context free grammar, and it is also known as ambiguous context free grammar. Now let us take one example for this ambiguity in context free grammar so that will be much more clear. One example here, let me consider S tends to SA or AS or A. This is the context free grammar which I have, and let me consider the input string as 5 A's. Okay, 5 A's are the input strings and the context free grammar is given. Now let us derive this 5 A's. First, let me start with S tends to, either you can take SA or AS. Okay, let me take SA first. Then in the place of S, again you need to substitute SA, right? SAA. Then again you have to substitute SA. As we are increasing the number of A's, till the 5 A's we get, we are going to substitute. So again we are going to substitute with SA. Then here in the place of S, if you substitute A, then you will get it as 5 A's, correct? So here what we have done, in the place of S, you have substituted SA. Again in the place of S you have substituted SA. Again in the place of S you have substituted SA. Then also you have substituted SA, and here we are done with 4 A's and the remaining one is A. So here you got one parse tree, right? Then if you start with S is the start symbol anyhow. So in the place of S, if you substitute AS, that means S tends to AS. If you substitute AS, here for the first time we have substituted with SA. Now I am going to substitute with AS. Then again I am going to substitute with AS. Then again I am going to substitute with AS till I get 5 A's. And here we have got 4 A's, and in the place of S, if I substitute one more A, which is, it becomes 5 A's. So if you draw the parse tree here, anyhow it is going to start with S, and you have substituted AS. In the place of S, again you have substituted AS. Again you have substituted AS till you get 5 A's, correct? So here, that means for the same input string 5 A's, you are getting 2 parse trees, which is nothing but ambiguity. Ambiguity in the context free grammar. So this is nothing but the ambiguity, where for the same string you are getting more than one parse trees. Again, if you take more than one leftmost derivation or more than one rightmost derivation, if you get, that is also considered as the ambiguity in context free grammar. So thank you for watching the video.